Hi, this is Miss G. So we're going to talk about molecular ionic and net ionic equations. So you want to have your yellow solubility chart and your periodic table. So molecular equations, basically we do the whole formulas of the reactants and products, including the physical state. So we have to identify the fact on the product side, whether we have it a solid or not. So the K goes with the nitrate and the lead goes with the iodide. So when we put them together, we get lead 2 iodide and potassium nitrate. So we look at our chart, and if you look down further, you'll see that chloride, if it's soluble, which means it's aqueous, but if it's hooked up with lead 2, it's going to make a solid. So that's why there's an S there. And then the potassium nitrate, if you look at nitrates, they're soluble, so then that would be aqueous. So complete ionic means that we're going to divide everything up. We have our 2 potassiums, and then the 2 iodides, and then the lead 2 and the 2 nitrates, and then the solid does not separate, and then we have the 2 potassiums and the 2 nitrates. So net ionic shows the physical state of the ions, elements, and compounds in the reaction. Only includes components directly involved in the reaction, which means the one that makes the solid. So when we're doing this, we're going to write the molecular, which is our formula equation, and balance it. Then we're going to do the complete ionic, separating the ions, and then we're going to write the net ionic. So when we write the net ionic, we're going to separate all the ions on both sides, and they are called our spectator ions because they're not actually included in the net ionic equation. So if you notice, like this will cross out on both sides, and then we have our 2 nitrates that cross out, and what we're left with is just the stuff that's involved in making the lead 2 iodide, which is the solid. All right, so we have aqueous solutions of lead 2 nitrate and sodium sulfate are combined. So first we're going to write our molecular. So we do Pb NO3 2 plus Na2SO4. So the lead's going to hook up with the sulfate. So we have PbSO4 plus the NaNO3. So we're going to look at our chart of our products and see if any of them would make a solid. So when we look at lead 2 sulfate, we see that sulfate is hooked up with the lead, so that's going to make our solid right here. And then the nitrate, we look that one up, and it's aqueous. So then we're going to balance it. So we have 2 of those, and then we're good. We should have aqueous here and aqueous there. All right, so our ionic is going to be separating all those ions. So we're going to do Pb, the plus 2, and they're all aqueous, plus 2 NO3 aqueous, plus 2 Na, this is a negative, that's plus, aqueous, plus SO4, negative 2 aqueous, makes, we're going to keep the lead sulfate together because that's our solid, then the plus 2 Na, aqueous plus 2NO3 aqueous. All right, so then our net, that's our ionic. So our net ionic is just the stuff that's involved with the solid. So we're going to get rid of the nitrates, and then we're going to get rid of the sodiums, and what's left is Pb plus 2 aqueous plus SO4 negative 2 aqueous makes Pb SO4 solid. And that's our net ionic. Okay, actually I'm going to skip this one, example 2. I think we're going to go to example 3 because it's not really a double replacement. All right, so we have potassium iodide and aqueous silver nitrate combined to form. So we're going to do Ki aqueous plus silver nitrate aqueous. So silver hooks up with iodide. If we go to our chart, we see that this is going to make a solid plus KNO3 aqueous. So let's see. They're actually already balanced, so that's kind of nice. So now we're going to separate it. So K plus aqueous plus iodine aqueous makes Ag plus aqueous plus NO3 aqueous yields AgI solid plus K aqueous plus NO3 minus aqueous. So that's our ionic. So our net ionic is going to be what's involved with the silver iodide. So we're going to cross out K's, the potassiums, and we're going to cross out the nitrates. So we have iodide plus silver makes AgI solid. All right, so we have aluminum chloride. Aluminum is a plus 3, so it's AlCl3 aqueous plus sodium hydroxide. Sodium's a plus 1, hydroxide's a negative 1, so they cancel. So aluminum's going to hook up with hydroxide. So let's see. So hydroxide's insoluble, so we're going to put a solid plus sodium hooks up with chloride, and this chloride is aqueous according to the chart. So then we can balance this. We put a 3 here and a 3 there. I think that's balanced now. So our ionic equation is Al plus 3 aqueous, we're just separating it, plus 3 chlorides aqueous, plus 3 sodiums aqueous, plus OH negative aqueous makes, we're not going to separate the aluminum hydroxide, so that's our solid, plus 3 sodium aqueous plus 3 Cl minus aqueous. So our net ionic is the chlorides are going to cross out and the sodiums are going to cross out. So then we're left with Al3 aqueous plus hydroxide aqueous So this should have been 3. Okay. So we need a 3 there. And then makes AlOH 3 solid. All right. Is that it?